Why was I oh, geez. Okay. I just realized I was speaking without so um so I guess I should reintroduce myself. I'm Ron Vedam with the Atlanta Functional Programming Meetup. For folks who have been seeing me talk mute, my apologies. I did not realize that I was on mute. Um, the AFP Meetup is a discussion for functional programming best practices. We host weekly meetups in Common Lisp on Saturdays. We also try to provide monthly talks on various functional programming topics. If interested folks are interested in giving a topic, I am Bugram on Functional Programming Slack, as well as folks in the Atlanta area. I'm also Bugram on the Tech 404 Slack channel. Feel free to DM me a topic, and we'll get you scheduled. Tonight's discussion is a talk on functional programming in Freepascal. I have some motivations about this. So I was kind of interested in looking at Freepascal for quite a while since I realized that I think about a month ago or a few months ago that Delphi, another Pascal variant, which we'll be discussing as part of tonight's discussion, um, introduced support for anonymous methods as well as something called function references, which is essentially function pointers, to allow you to create and pass functions as arguments to other functions. And this motivated me to kind of like dive back into uh, free Pascal. I mean, Pascal has a programming language. Additionally, there was another paper that I was reading on a common Lisp library called Series for functional programming, and it turned out that the author of that library and proposal, because it actually ended up becoming a language in, sorry, a library that was proposed as being part of the standard Common Lisp library. He actually went ahead and introduced this as a generic pattern in Pascal, using a preprocessor and standard Pascal. And we'll get into some of it as part of today's discussion, but I wanted to see, given some of the more modern features, how that might look like. Um, so our agenda is tonight is really going to be covering four different things. I'm going to provide a brief history of the Pascal programming language. I feel it's appropriate to do this, especially given the fact that, as someone pointed out to me the other day, Turbo Pascal, one of I think it was the first IDE I ever used, turned 40 um, over the weekend, and it felt appropriate to give its due respect, especially given the fact that it had influence on Free Pascal, which we will be looking at today. So going back and kind of looking at where we are and where we came from would be very, very useful. I will provide a very brief overview of what Pascal is in terms of syntax, because we will be seeing some code examples, particularly focusing on functional features, but it will give you an idea on how a Pascal program looks like. And then we will look at various code examples specifically for the functional support that Pascal provides. And then hopefully by the end, I can give you some conclusions and questions, time permitting. So first, a brief history. Pascal has, I'm sure many of you probably know, although fewer and fewer as time goes by, was a programming language invented in 1970 by Niklaus Wirth. Okay, or as us Americans tend to pronounce it, Niklaus Wirth. Posing the joke that Europeans call him by name, but Americans call him by value. Uh, uh, Wirth was already at the time a prominent computer scientist. He was actually a member of the Algol 60 committee, and was part of the Algol tradition and was involved in syntax. He also invented some other languages prior to Pascal, such as Algol 68. Well, no, not Algol 68, Algol W, which was a simplification of Algol 60, and its innovations and inspirations kind of ended up going into original Pascal. Syntactically, for folks who have seen Algol 60 And I encourage you to look at some of the examples that are on Wikipedia if you haven't done so. Um, it follows the Algol 60 tradition. Block statements are using begin and end. It uses a uh, a grammar that lends itself to being simplified and allows it to being easily parsable. And it supported uh, very basic things like mainly imperative and procedural programming, a notion called structured programming, which very few people have encountered these days in modern times because we've kind of favored locality over what uh, Pascal was kind of encouraging at the time, where you have what's called a single entry point and a single exit point. Declarations are usually all the way defined up front, and they are usually well aware, well away from the actual logic where those particular variables and declarations were introduced. Records and abstract data types. Well, you had abstract data types and larger data types created through the record data type, and this was extended later on in other successors of Pascal. But this is kind of the what we would consider standard Pascal, and it became kind of notorious for some of the stuff of this, and I'll bring it up a little bit later. And like C, actually, in many languages that were designed at the time, it had support for pointers and manual memory management. Pascal kind of inspired um, four pretty major languages, and I would say some of them kind of all fall in line with the Virt tradition of simplicity and emphasizing teaching, because Pascal itself was designed to being simple enough to do real programming, but it should be used to pick up by a student relatively quickly, so they could get and hit the ground running. This cannot be understated because its simplicity even still stands today compared to some of the programming languages that we often encounter in today's day and age, with some of their some many concepts uh, providing that could uh, confuse the incoming and beginner computer science students or person who's trying to get into computer programming in general. This simplicity was not lost in the successors that Virt personally designed, which includes Modula and the Oberon family. And Modula and Modula 2 are basically the same language, and we'll be discussing that in a second. But I wanted to kind of mention that Virt, from my reading of some various um, uh, articles on the internet, obviously take it with the grain of salt on some of this. I would say that Wikipedia's resources and references seem to be pretty plausible on this. He had some consulting knowledge and business uh, involved with Object Pascal, and as well as that influence in Object Pascal and its design for OO influenced Delphi a little bit, and it's a successor. So all these languages kind of influenced each other in some way, shape, or form. But the main two that Virt was personally involved in is Module 2, and the Oberon family. And in fact, just a little side note, well, we'll get to that in a second here. Let's talk about Modula. All right. Um, Modula was the immediate successor of Pascal. Okay. And it supported essentially imperative structured modular programming as well as concurrent programming. All right. Its approach to encapsulation at the time, because you got to remember, Modula came out, I think it was 70, I believe it was 78, is when Modula came out. All right. Um, and it was subsequently, it's, it, at that time, they were still looking into, um, what's it, object-oriented programming, because Smalltalk 72 just came out at this time, and And Viert actually spent some time at Park, and after seeing the Mesa programming language, which was a Pascal-like language that the Park fellows introduced, he took it upon himself to, you know, uh, took the design, the ideas from Mesa, and create his own sort of attempt at simplifying it, but a Mesa derivative, right? Through this, he introduced encapsulation, both data encapsulation through for variables and record types and so forth, as well as procedural encapsulation through the use of modules. Okay, these are actually the modern term of modules that most people tend to ask for in various programming languages, C++ being one of them. All right. It actually formed the basis of separate compilation of different units, which is particularly notable to realize. And This is actually one of the criticisms that was addressed from a paper that Brian Kernighan wrote when he was using Pascal at that time to write software tools in Pascal. More on that later. Modula also and Modula 2 subsequently supported coroutines, right? Which was a Modula's approach to concurrent processes and cooperative multitasking. The reason why Modula and Module 2 both kind of go hand in hand is because Modula came out in a paper, and my understanding is Viert uh, immediately went from publishing that paper and going straight to Modula 2. Um, so it's specific. It's particularly interesting. Um, Modula 2 actually was quite successful. It actually was used by Digital Equipment Corporation in various efforts. Some of their most notable papers on threading and multi-threading were all kind of implemented in Modula 2, in Modula 2 Plus. But they also made their own Modula successor with a little consulting help from um, Virt called Modula 3, and that was used to actually implement a full operating system called the Spin operating system. That's available actually online if folks are interested in taking a look at. The reason why it's not introduced in here in this particular piece of history is mainly because of the fact that even though Virt was kind of involved in it, he wasn't a he was more of a consultant more than an active contributor to that effort. Um, in about 85, 86, Viert again went down the road of creating a new machine and tried to reduce Modula 2's complexity while increasing its power in terms of supporting for data abstraction through the use of creating object-oriented programming or support for object-oriented programming into Modula 2. And that's what ended up becoming Oberon and its successors and its families of programming languages. So again, as you may note, the three core paradigms of imperative, structural, modular that kind of was picked up in that Pascal's tradition that still stayed inside Oberon, but now it introduced object orientation through the use of something called type extension of record types to allow one to perform inheritance. This was another way also to allow you to do in combination with the modules to be able to do things like dynamic dispatch and things like this. Um, they have built-in type tests to be able to test between different types for dispatching. And Oberon had constructs for isolating unsafe code. You can see actually through this feature here that Oberon, Modula, and all this kind of their ideas kind of leaked and inspired many successor language. Is mainly things like Java and C Sharp, where you do have these abilities now to actually mark things as unsafe when you're isolating unsafe code. being able to do things like having modules inside for a separate compilation, and some extension stuff for record types is inside successor languages that from this family from Oberon. Um, Oberon mainly was focused on limited system programming. Um, so to that effect, it was actually explicitly designed for an operating system, for designing an operating system and implementing it, and that's the Oberon operating system. You could see actual videos of people using this system. Its particular main innovation is it was a text-driven interface. I wouldn't say so much like curses, but you can that's the closest analogy I could come to for folks who's never used this. But it's text user interfaces meets hyperlinking. I encourage you to go and look at videos on Oberon's operating system. They're all kind of available on YouTube to be able to kind of check out its power. It was particularly influential to Rob Pike, who ended up later on designing the Rio window manager out of its ideas and the Acme text editor for Plan 9, the Plan 9 operating system. So what does this have to all do with uh, Freepascal? Well, there are two additional things that come into this story. These three languages were all happening at the same time, three efforts from Niklaus Wirth. And at the same time, there was a second group of people that was actually adding support for object-oriented programming in what we consider to be the similar style of object-oriented programming. So defining classes or objects, all right? The first one of these variants is Object Pascal, and it approach of creating objects and classes. It has two different types. One was extending records with the ability to add methods to a record, and that's what they call objects. And then you had classes, which actually also provided you what's it? Public, private, and protected kind of like access permissions on top of access control on top of the members of your class instances. So both are supported in this variant of dialect of Pascal, and it ended up being the main programming languages for the Mac application framework for both Lisa and early Mac OS until I think it was 1991 or 92 from what my reading is. Some successful applications that were written in this early versions, really early versions of Photoshop were written in this before they moved over to C++. Um, there were various Apple Talk kind of applications that were written in this. Core services for early Mac OS were written in Object Pascal as well. So it was pretty heavily used at Apple at that time up until at least 92, 93. Delphi is a dialect of Object Pascal in that it adds to Turbo Pascal 5.5, which all of us are most familiar with. It's actually also known as Borland Pascal, because I should mention, just because after I think 6.0 they renamed it. Um, it took a lot of what Object Pascal provided and it added it to this, but also recently started adding features for functional programming. All right, mainly support for anonymous functions and function references. We'll touch base this in the next slide. All right, actually in a few sections. All right. Freepascal basically is an open source compiler and variant. Technically, it's also a variant of Pascal and Object Pascal. Um, and by that I mean is the Object Pascal dialect that Freepascal provides is the Object Pascal that was originally Component Pascal from Apple, but it fixes a couple of issues. I couldn't find the specifics of what it actually fixed. There was a couple of limitations of those earlier components, Pascal and Object Pascal things that were limiting that it took out. Um, in addition to this dialect, though, it provides various support for many dialects of Pascal. Okay. At this point, I'm sure the astute audience member is going to probably be thinking, if Pascal was a standardized language, which it was, why were there all these variants? Well, this goes back to some of the limitations of the Pascal programming language that I wanted to kind of briefly touch base here. It could be actually the topic of a talk, just because it was written in a 16-page paper by Brian Carnigan called "Why Pascal is Not My Favorite Programming Language." You could certainly look for that. I will post that in the um, YouTube description for folks who want to actually read it. It's actually a really good paper. But to put it pretty simply, for the sake of tonight's discussion, there were limitations to the creation of generic subroutines and libraries for use in larger programs. That it became very clear when designing software tools in Pascal that Pascal really did um, uh, market itself as a teaching language and really did it to a fault, in that you can learn Pascal and really learn programming, but at the same time, you won't be able to design anything larger than a particular sizable system. All right. Now, some of these issues that were mentioned in that paper um, were addressed in later versions of the successors of the Pascal family, Modula, Modula 2, and the Oberon family, as well as Delphi. But um, simply put, at that time, because of these limitations, each person, each compiler, each university ended up adding their own extensions to the Pascal language to make it suitable for large scale programming and programming bigger systems, right? Of these, Borland Pascal was one of them. It actually ended up adding a bunch of stuff that a lot of rapid application developers in the 90s are familiar with and love. These ended up going into Delphi as well. So things like, I'm sure most people are in the younger audience may not know these. So there were libraries like OWL, which is the Object Windows library, which I think is written in Pascal. There was the component library, the foundational component library, which was written in Pascal, that was giving standard collections and things. These are actual extensions that are not part of the standard, but they are available in Borland Pascal and its variants. And they actually fix some things like um, there was a known limitation for Pascal in creating dynamic arrays. All right, you can only do fixed size arrays. In So basically arrays with a specific maximum bound. All right, and the reason for this was is it enables bounds checking at compile time. All right, obviously we've since then figured out better ways of actually addressing that particular limitation, but at that time that was something that uh, Viert thought would be complicated to teach beginner programmers, so he ended up thinking that fixed size arrays would be um, probably the better approach to actually teaching people using arrays. Um, And since then, Borland and Delphi both have changed their views. Object Pascal also for dynamic arrays. But again, this is another thing that actually motivated the variants. So Free Pascal actually took the majority of the most commonly used variants and provided support for them. And the way they did it is something we will actually see in the code examples that I'll be showing you. Quick overview of the language in terms of its structure. Free Pascal contains kind of three major, like you could think of them as units for compilation. Okay, the first thing is program, which is individual programs. This is what you would normally write on your day-to-day basis. The second thing is units. So if you want to create libraries or subroutines that want to be used across different programs, you would create a unit of compilation, and you would then use the uses keyword to actually go and use that particular module. Uh, most all actually even today, all free Pascal units, from what I can tell, are statically compiled. So these units, these modules will get parsed as part of a single pass strategy, and it will ultimately end up getting statically linked and create a single executable. You might see in, at least on Linux, some stuff related to objects, but those are just mainly intermediate separate compilation modules that are going to be used to completely statically linking later on, much like how your C++ compiler compiles .os before actually doing a linking phase, right? The third unit is more for operating with the external world, specifically the C world. So if you want to interact and use your free Pascal libraries with C or C++, you can use library units to create shared objects or DLLs, and define what symbols to export from those units or those modules that you're defining. You can actually also define all your stuff in the library itself, and then just simply compile that. That's another strategy, and we'll see um, uh, a quick structure example on what a library might look like. So this is what a program structure looks like. You have your program, the name of the program, then you list your types. Uh, this section is potentially is optional. You list your constants in its own section. You list your procedures or functions. Okay, so Pascal supports procedures, which are void functions basically, and functions, which are functions that return a type. uh, that's their distinction between these different types of subprograms, which kind of makes sense if you look at it conceptually. In that a void function, even though because it returns nothing, it shouldn't really be called a function, but we're using function to mean something slightly different than what it intends. So procedure replaces void function, and functions can now uh, be used in a mathematical sense, in that they take in an input and they return an output. So for folks who are looking at this and are thinking, well, what if you wanted to take an input, modify something in memory, and then return an output? Could you do that? I haven't tried those examples because I'm still kind of diving back in, so to speak, in this realm. Units have a similar structure to programs. The only difference is units require you to specify a public interface. So that's the interface is basically your declaration of all your functions and all your types and all your constants. And the implementation is just their definitions for uh, uh, internal compilation. So what happens is you could think of the interface section as being your header file, and the implementation section has your .pas. They, for whatever reason, I'm still wondering the motivation behind this design. They separated the type declarations and APIs from it, and I'm guessing during the parse phase, they use this information to quickly parse and create a symbol table without having to worry about parsing the definitions for each of the procedures and functions to create the final object file for that given unit before compiling other potential units at the same time. One thing to note about this is libraries can have initialization routines and initialization functions. So this section here where you have a var variable section and begin, this unit initialization will happen when you do uses. So behind the scenes, when you compile your .pas and you're using one of your units, or you're using a unit that has some sort of unit initialization, at and you can look at the actual assembly code on this, but it does something interesting. It actually goes and invokes this call as a separate function call. So all your initialization stuff happens in this nice kind of clean unit. Okay, you don't have to have it separate. And the compiler is aware that whenever a unit is used in some other program or other unit for that matter, it will initialize the code if it hasn't been initialized, and then subsequently call the routines accordingly. So this allows you to have some sort of encapsulated state essentially to leverage at the time of your library invocation. Libraries, again, very quickly looks like units. The only difference is this exports section where you have symbol exports, but the code and structure of it remains the same. So let's talk about functional features here. So in Freepascal, there's technically two different ways of dealing with functional programming, depending upon whether or not you're using the Delphi dialect or you're using the Object Pascal dialect. Okay, the Object Pascal dialect it has very limited support for functional programming. The only thing it really has, and this is very old, I think it's been around in Pascal even, in at least later versions of Turbo Pascal, it certainly was. You can pass in functions as arguments to other functions. Those functions have to be defined as named functions, but you could certainly pass them using a notation that I will show you in some of the examples. But and also my understanding is you can also assign functions to variables. But again, those functions would have to be predefined as named functions, probably in a unit somewhere if you want to stash them, and then leverage the appropriate units. Sorry, the appropriate functions at the appropriate time. But the point is those functions cannot be anonymous. They must be labeled. Delphi, on the other hand, now with version 3.3, well, it was introduced in 3.22, but in the 3.3x line of FPC, the Delphi dialect now treats functions as first-class citizens, or for the most part. Okay, I haven't hit a situation where I can't do something. All right, so I've tried examples for creating anonymous methods, closure support, function references, which is basically allowing me to pass functions as parameters into other functions, and I could certainly return functions from other functions, which means I can make function factories or closure constructors too as well. So let's look at some code. Let me share my other screen. Give me a second here. Jitsi is kind of weird for doing this. Window. Um, okay. Okay. All right. So the first thing to look at is before we get started on the actual functional features, is how do we switch between the dialects? All right. There's this feature in FPC code called the compiler switch. I think it actually comes from the Borland line of compilers. I don't remember where I first seen this, but the idea is basically this mode switch right here at the top allows you to specify which dialect you're actually using. So here we are treating this program as a Object Pascal dialect program. All right. Now, it's important to know this mainly because from the standpoint of compilation right now, if you are using object Freepascal in this case, but it's object Pascal, all right, you are expected to use units that are also compiled using object Freepascal. There's no way of technically mixing and matching here, all right? And I'll talk about this in kind of the later final discussion about the differences between these two, but this is certainly something that I stumbled on that I'm going to just, upfront tell you. The one thing to note here is when you're defining your high order functions, you have to in Pascal provide them a type. Okay. You cannot act, and I mean specifically a type alias. Okay. So you see this int to int function here is basically a type alias to any function that takes in an integer and returns an integer. Okay. The notation of defining the function does not change. The names of the parameters have to be present. Okay. This is specifically also because of the fact that since we all grouped variables of one particular type have to be upfront specified. Um, uh, this allows you to do a quick parse. So if you're doing multiple, if you're going to be passing in two integers, as you might see in later examples, you will be x comma y colon integer. You won't say x colon integer, semicolon y colon integer. All right, that actually throws a compiler error. Once this type alias is defined, you can now use it in your function declaration. So we can see here in line 11, our function declaration of sumInts, which will be a higher order function defined. Essentially, you could think of this as summing based on transforming a particular value in each value in a particular array to through the transform function and then taking its results. All right. Um, so the name should be some transformed ints or something like that. But regardless, in this example, what we did is we've provided a dynamic array of integer. We took a transform function, and then we've simply looped through the array and returned the result of the transformed array. A couple things here for folks who are new to Pascal, and specifically Object Pascal, because um, earlier versions of Pascal did something different. Um, this keyword here, result, is a special keyword. Okay, when you are using it, it does not have to be declared. Okay, its type is already known to be equivalent to the return type of the function upon which you are using it in. Okay, so Pascal knows ahead of time that result is going to be of type integer. Okay, and it will throw an error if you try to use another type on this, just because it'll look at the signature and give you an error. All right. In older versions of Pascal, standard versions of Pascal, most people are familiar with this other syntax here, which I'm just going to briefly show. And that is you could take the return value of a function is basically what has been assigned to the name of the function. So square int basically is telling the compiler square int is my return value now, and it will return it. Notice there's no explicit return in this code here. Okay, that's another thing. We do not need to provide explicit returns. In the case of the result code, it will, once the final code in line 19 executes, results is assumed to be done, and it'll be the last thing that gets returned. It'll get injected into it. There are early returns in Object Free Pascal. You have to, I'm just not showing any examples here where we are leveraging it. Okay. But it is there. For folks who want to entertain using it. Okay. To use this higher order function, okay, and I'm just going to also show this too as well. Let's go ahead and you can either call it directly, which is line 50, or you could create a parameter of the type into int function, and and then also assign to it square int. And if you call it using this, this will also work. I'm not, oh wait, this should, we'll see what happens. Wait. Yeah, this here is already a function. Oh, sorry. There we go. So this brings up the error is kind of what I is what I'm going to was going to talk about next. But so the one thing here is these functions that are being passed the way they are actually technically function pointers right here. Okay, you don't need to explicitly say that this is a function pointer. Like most people who know and have seen Pascal in the past have actually are probably familiar with the pointer notation in Pascal. Okay, so if it's like a p-int is basically a pointer to an integer. Okay, you could do something like that. Once I actually spell right, yeah. And this also is a valid type, and you can also call it here inside here x equals the p-int. Now, you don't need to actually, by the way, create a type aliases, but it's normally good Pascal practice to actually leverage it. And you could then assign to it normally. And it will, you do, if I remember correctly, hopefully I don't mess this up, new x to allocate. And then you do x to dereference. And then obviously you need to dispose x to delete. And this will all work. Variable identifier, line 44. Oh, sorry. There we go. Dereference on Pascal is on the right hand side, not on the left hand side. Habits from C++ and C kind of switching between languages with different notations tends to mess you up sometimes. So, but this is just very quickly to show the pointer syntax. With function pointers, you don't need to do this. All right, function pointers end up being already pointers. All right, and to provide the alias to the pointer here is you use the @ sign in object free Pascal to pass this in. So if I, for example, decided to do, instead of squaring an int, let's say I create a function called double, double int that takes an integer, returns an integer, and then we say begin double int 2 times x, and so now here I can just simply change and reassign this to double int. And here I can actually see that the code will actually still compile and execute as we expect. Okay. So this is free Pascal's thing. You can totally go and create large programs and large medium sizes with just function pointers as it stands today. Okay, with this. Obviously, this isn't this is functional like, but it isn't completely functional, right? Because I can't return functions from functions. I can't create closures with this notation. Um, uh, there's no way of actually doing what's it some types of high order functions to actually go and address this. All right, which brings us to what Delphi does. Okay, the Delphi dialect. So I'm going to just show you the basic example of the Delphi dialect to begin with, and then I will show the a more complicated one that I've been trying to start working on that leverages Freepascal support for Delphi and object Freepascal support for generics. Although I'm using the Delphi dialect just because the Delphi dialect is a little bit better. So let me just pull up this guy. Any questions so far from anybody either in the audience or? Okay. So let's start at the top. Okay. So to start with, just like before, we're using a compiler switch here called and we switched from object FPC to Delphi. There are some additional compiler switches here that I'm using. So this is kind of the mode switch to switch dialects, but this $H plus is dealing with some warnings that is kind of irrelevant to the discussion right now. But this here, just know that these are, you could provide different types of controls to the actual Pascal compiler um, to actually deal with different types of warnings. I'm forgetting which one this one was specific. I don't necessarily need it here in this case, but I'm just going to leave it here for the time being. The two things to know about though is if you are using version 3.3.1, all right, I had to compile the Freepascal version of this because it's still in development. From my understanding, it has not yet been released. So this is kind of fresh off the presses, so to speak. To turn on anonymous function support and function references support, you have to go and actually put these things called mode switches to say, okay, and these are kind of like free feature flags for the compiler, basically. So you're saying turn this feature on for anonymous functions support and function references. Eventually, this will go away. You will not need this at all for your uh, for your programming purposes. But to try things out, it becomes important. Okay. Um, so like before, we have to use type aliases to define our functions. So the difference between before what we saw, and I guess a side-by-side comparison would be more useful. Let me see if I can actually do that for you folks. Let me go ahead and expand this a little bit. Okay, and functions. Okay, if you notice here at the top, our function pointer basically took this function x has integer and returns integer, but now we basically said, no, you need to provide a reference to it, okay? This reference to function is basically a function pointer, okay? My understanding, and you will see if you try to do this, I don't know if this will work, but I don't believe this notation works in the Delphi mode, right? No, this actually does work. So this one actually is a different thing than this. Oh, that's right. I'm confusing myself. So function pointers also work in Delphi, but in addition to that, function references, which is basically providing an alias to the function pointer, the location. So you can think of this as yet another name. Okay, your whatever you assign it to is yet another name. That actually can be then used internally as a function, but you don't actually are pointing that reference. There's a way of actually it implicitly knows that this is a function call, so you don't necessarily need to pass it. You don't need to use the at sign to actually assign a uh, a function to this value, this a variable that might be of this type. Okay, and we'll see an example of this in a second here. The rest of this code will look the same to you. I don't think I need to kind of review this here. Um, the main differences will come in later on here. You could see that now when I tried to call this, I no longer need the at sign. I guess that's another thing I should show, which is here. as you can see before, to pass this in as a pointer, I'd have to say at, which is pointer of this call site, and then return. But now with function references, that no longer is needed. You could then, obviously, just like before, int to int function. And I think I'm using the wrong thing. There we go. And let's go ahead and quickly create our double int function for this example. Okay, so now let's see this. If I do f equals double int, and then do this sum of doubles, and we call the function on this, we run it, everything compiles. You can see we have our sum of doubles. If I go in, reassign this to square int, and then create another sum of squares, you can see this all kind of works as well. All right. On top of this, we have the ability to create functions that return functions. Okay, so let's quickly make the canonical example of this, which is make adder that takes in let's do this. Integer returns an int. Returns actually, we have to create actually a type alias here. Let's say call it by int function, which is a reference to function xy integer. Actually, this is still a no. This is going to be a int function because of the fact that we're creating a closure here into int function for this example. So now we just do begin return function that takes x integer, returns integer, begin result equals, oh right, I have to do this, result equals, and in this case I'll probably use make adder to make things easier for us to read, and just go do that. And this should first compile. Let's check. Good. So let's go ahead and use this. Let's make a add 3 function here. Make adder 3, and let's write 2 plus 3 equals add 3 to 2, and you have, oops, I forgot to actually define the function here. There we go. And you can see that this defines our anonymous, our function factory. So this kind of shows that we have closure support. We have the ability to create an anonymous function. Anonymous functions are anonymous functions or anonymous procedures. So if you have a particular type of procedure support is available here. I'm not going to provide examples of procedures just because I can't think of one off the top of my head right now. Maybe I could just do, well, let me try. I can do this pretty quickly. It's like a display function. P void function. And let's say, actually, let's call this void procedure int Wow, in dark, just so that I know what type it is. And then I'm going to go ahead and say that this is a reference to a procedure that takes x as an integer. And we're just using this to kind of show that you can make a dummy like display function if we wanted to. So let's say we wanted to create a display function that is void. You could certainly do that. So now display could be assigned to a procedure that takes x as an integer, begin, write line. Let's say x to make things easy, and let's just say we are displaying may add 3 to 3. Begin expected, and hold on, I may have messed something up here. Oh, I don't think I need to do this. There we go. So this is all good. We've now seen that we could create higher order functions, we could create closures, we could create we could pass functions as parameters into other functions. So we could create function factories like we've seen earlier. Yes, there's a question.
Rom, so were you typing something there? Because my screen hasn't updated. My view of your screen hasn't updated.
Really? Hold on one second.
You were typing a whole bunch of stuff and nothing ever changed on what I was looking at.
I was typing something earlier. But hold on one second. Let's see. Let me, it looks like my screen was showing up on the screen. Let me see. Let's try this again. Can you see my screen? Have others been having this issue?
Yeah,
For
I can
me,
see.
and I can see new stuff now.
Was it stalled earlier?
Yeah, it was all for me for a couple minutes.
Okay. All right. So where, I guess, is the question that again, I wish somebody who spoke earlier. Where in my discussion did other people have uh uh did folks get stalled on? I guess is a question, is my question.
For me, it stalled when you were on what is it, line 56, right? It stalled right after you typed AD,
Okay.
and
All right.
then
So
so add three and
okay, I
display
will
and all that.
I'll quickly go through this. So that's um it's not a big deal. Thank you for letting me know. I appreciate. Um, please, if there's any sort of technical problems right now, I know Jitsy's been having some weirdness that I've been trying to deal with while we're having these conversations. Um, so it's a little surprising that I'm not surprised that this is kind of happening just because they're saying that they're running out of resources. Um, so uh, so earlier in our discussion, and I'll just kind of repeat what I did as a code review. I created a function factory to create adders. All right. Um, Now to use this function factory, I have I have to create a variable as I did here in line 56 to hold the return value. Okay. Again, this code is highlighting the essence of what Pascal considers a big feature, which is structured programming. You have to declare your variables up front. Normally, you would want to declare add 3, which is on line 56 near line 78. Okay, because that's where we're using it. But because Pascal doesn't allow you to do variable declarations in line within the begin and end block, you have to actually put it in the variable section. So add 3 is basically what we're going to be leveraging later on in line 78. Okay. Once defined, we can then use it to hold the return value of makeAdder. Okay, makeAdder is returning a function reference. Okay, and it's not a function pointer. It's not dynamically allocating this individual. So this should do something equivalent to like return value optimization. But put it simply, it's returning a function pointer and assigning it to add3, and then we can go and invoke it directly like it. The pointer stuff is all hidden to everybody. You do not need to even think about it. Okay. The main thing you just need to know is makeAdder returns a function, and once it's assigned to a variable, you can invoke that function. Okay. But it's not just functions. You have the ability to also create anonymous procedures. Okay. Um, in this example, in line 9, we created a type alias called void procedure int arg. Okay. To use this, again, just like any other structured variable, we declared it in line 57, and then we assign it the following way. Anonymous procedures, okay, like anonymous functions, um, allow you to use the same old syntax. The difference being is, and I think the easiest way to do this is to show you how the anonymous function looks like, is function versus procedure and return value being specified after the argument list. Okay, but the rest is the same. You are not supposed to. Whereas when you're defining a function or a procedure, you have to provide a semicolon before the beginning of the block. When you're defining an anonymous function, the semicolon is not needed. Okay, this is treated as a single parsable statement inside of Pascal. Okay, same here. This here, from the procedure to the end, when you're dealing with it as an anonymous procedure, no semicolon, so it's treated as a single block, and it's then going to be parsed in a single pass. Okay. Now, these are the basics to show kind of that, yes, as it stands today, for all intents and purposes, um, in the Delphi dialect of Freepascal, and FPC has full support of this, functions can be treated as first-class citizens for the most part. Okay, I haven't hit a situation where it hasn't shown me that they're not first class here. But that isn't to say that there isn't a downside to this. Okay, because one might think, well, this is great. I could start inlining functions, right? I'm going to show an example of some work that I've been doing to kind of illustrate uh, how weird it can get. Okay, it could become a bit unmaintainable. Okay, because mainly because of the the uh, the begin and end blocks could cause some complexity in the larger code. So let me see if I have this open. I think I do. Okay. So first, I need to give the example that we're going to be dealing with. Okay. So here we have created, and I guess really I should also show this. Okay. We have created essentially 3 type aliases here. Okay. One for predicates, unary operators, and generators. Okay. To generate um, uh, different types. Okay. Um, this is one way of creating something like a scanning object, okay, that will generate different types of values that you are providing, and then you can return to it. Okay, I created using this following the series paper. I was starting to look at the series paper, a scanner that basically takes an initial value z and the unary operation, and return a generator based on that. And what that's doing is it's creating a closure here by first assigning z to um, x so that it could be closed over the actual anonymous function that's being returned. There could be a better way of doing this, but this is my current first pass that I did for this. And then we end up calling the predicates to see if we can continue generating generating values for this given function generator, and we return it. Okay. You could already see here, because of some of the complexity, that it is getting a bit unwieldy in terms of where things begin and where things end. Okay. So here, so this is not too bad. Okay. But when it's being used, it could get a bit unwieldy. So let's take a look at this. This here is me inlining a anonymous function that is being passed in, has the generator, the step function, and the anonymous function that is the predicate as to whether or not we need to continue to generate or not. Okay. And this already is like you could see this. If you have a complicated lambda function, this is still a lot of boilerplate, a lot of code for folks who are used to lambda functions in other languages, right? And anonymous functions in other languages. Seeing this in a larger code base, it could even become even more complex. Now compare this, or even this here, where we're passing in a anonymous function to reducing on an input array. Compare this to just calling multiply, okay? And you could see that in the case of Pascal, the simplicity and the parsability of the language, without actually adding the extension to make things concise, for where it's better to actually put in one-liners inside of a function call. It's actually here at a it's being used at a disadvantage. It is because it's actually making the code a little uglier to read and uglier to kind of understand. Okay. I mean, obviously anybody who reads this can clearly know what this is, that this is being a block. But my point is that um, the it could get unwieldy if you have a fairly complex anonymous function being generated. But that's general bad practice anyway. If you're creating an anonymous function that's more than a few lines, all right, ideally it should be one line. But some folks say more than a few lines. Then really you should make a named function and then return it. Okay. Don't try to act smart. Okay, that's really a bad idea. Okay. Um, Before I move back to my presentation, because I do have a few slides left, um, I do want to also point out one other feature, and that is, once an anonymous function is defined, one neat thing is you can actually immediately invoke it, just like any other anonymous function in other languages, which I thought was also pretty useful in some situations. Okay, so let me go back to my presentation here. Okay. I may as well double check. Can folks see my screen again in my presentation?
Yeah.
Okay, great. All right. So my initial impressions on gave me some pros and some cons. The immediate pros is folks who know the language and know the dialects, they're using the existing syntax. So there really isn't any learning that a person needs to do to leverage these features today. Okay. And as you saw, the integration with the existing infrastructure is just seamless. All right. I haven't hit any issues using the syntax, other than some, odds and ends here and there from just using FPC as a compiler in general that I would bring up. But there are several cons also that I've seen. One, as I was mentioning earlier, anonymous function inlining can lead to some pretty complex code, um, particularly for folks who are notorious for writing some pretty convoluted anonymous functions that do some pretty weird black magic tricks to actually get some things done. Not saying that that's not cool. I'm just saying that it will create unmaintainable code. All right. So use with caution. A bigger thing that I think in general, and this is actually more of a criticism of FPC, and that is uh, if you use the FP constructs and create a library that was designed in the Delphi dialect, you can't actually use it inside of object free Pascal. Okay, you will get an error. I didn't want to kind of show an example of this because the errors that you get is actually dependent upon how it dispatches to the particular dialect parser that uses it. So it doesn't make much sense to show you errors that are basically parsing errors because we're using the wrong dialect. But for folks who are willing to give it a try, just try adding a mode or obj FPC in one file and mode Delphi in another file, and you will see what I'm talking about in terms of this. Um, it's particularly bad because the library that I was creating earlier, that's written in the Delphi dialect, that by default will not be able to work in object free Pascal using the notation that I was using earlier. And that's kind of a sad thing to really to have that, especially if you're trying to create a library that's being used in as many dialects as possible. So this is kind of a impression that I had with FPC in general. So to sum up, FPC is an open source compiler and variant of the Object Pascal language and has support for Delphi and other Pascal dialects. The dialect that FPC supports natively, that is not Delphi, has basic support for functional programming through the use of function pointers, as we saw earlier. But the FPC Delphi dialect, as of the latest version of the compiler, can more or less be say it has support for functional programming based on the experiments I just demoed to you all today. So functions are first-class citizens. There is some future work that I want to do personally on this adventure. One is, as you saw earlier, the series library. This is again a paper that was created by Dr. Richard C. Waters. He actually created originally the library in Common Lisp, and he wrote it as a functional library. But he actually generalized it and created a Pascal variant and created a subsequent paper called Optimizable of Series Expressions Part 2, where he showed his Pascal variant that he created on top of, at the time, this was published in, to give some context, in the early to mid 80s with standard Pascal. So he had to create some preprocessors to create his library. And I'm now wondering, well, since we have in Delphi at least some of these first class function constructs, would it be possible to create the library today? And can we see some of the, some performance advantages of using these actual features? Additionally, I want to create a kind of a larger program with the functional context to really see what the limitations are and in terms of their visibility. I will say at the outset that if I'm creating it, I would I would encourage the use of named functions in terms of variables at least assigned to the function return values rather than passing them inlined, just because it just adds more lines to the program based on my current impressions. Now with the one-liners that I saw earlier, adding 5 additional lines may not sound like a bad idea, but I have to create a larger program to really see that the limitations in it. And I honestly have a gut feeling that if this becomes like thousands and thousands of lines of programs, I will find myself say basically creating new variable names just so that I know which function I'm using. And that could actually encourage more reuse rather than people constantly writing x+1 in multiple places or whatever simple one-line functions we tend to create. Questions? Comments, thoughts, insults, you know. I'm opening the floor for anything now.
Well, Ram, interestingly, I've been cleaning out a bunch of old crap. And part of that old crap is the August issues of Byte Magazine, the issues that they devoted to languages.
Mm-hmm.
So one of the ones that I looked at recently was about Pascal. And the one I'm looking at right now is about Modula 2.
Nice.
Which is in August 1984, right? And so, I would have been completely lost at what you were talking about if I hadn't looked at these things recently and kind of gone, oh yeah, Pascal. I haven't thought about that in decades. But one of the things, especially looking at this Modula 2 issue right now, is looking at or reading Wirth's reasons for designing Modula 2. And it just seems like I don't understand quite why Pascal would be that much of interest. One of the complaints about Pascal is that you have to go through and you define these things right in a particular order. You have to have a label section if you have them. You have to have types. You have to have constants. Then you have to have your variables, and then you have your procedures. And originally, did Pascal originally have a function statement, or were they both procedures?
No, they were function statements.
Functions.
Oberon actually consolidated them to just procedures, but
Modu-
Pascal was functions and procedures.
okay, yeah, I couldn't remember. Modula 2 has procedures.
Only procedures.
Only
Okay, then it was
procedures.
Modula 2 only has the one that got rid of functions. I wasn't sure if it was Modula 2 or Oberon. One of the successors actually got rid of the function keyword. So
Yeah, and again, it's not like I have an encyclopedic knowledge of it. It's because I've just been reading these articles this last few days. But so Modula 2 introduced the return statement, so it could a procedure is a function if it has a return statement. Okay, doesn't seem like a big gain to me, but that structuring of it, and you kind of alluded to it a little bit when you were talking about some of the code, is that you can't structure your code statements kind of in a logical way.
So I would make the Pascal and its variants. Okay. I will say this. It encourages a very different style than what we're mostly used to. All right. When Pascal encouraged structured programming, its kind of thought is people will create a lot of small functions. All right. Small enough where the locality from where it's being declared to where it's being used is very, very close still. All right. And they would then compose these generic subroutines to much larger routines. All right. At least that's the idea. But it became clear that sometimes when people are designing systems, all right, that especially for certain types of functions, that kind of separation is very hard to do. All right. Now, I'm not saying that this means that they were wrong. Pascal was wrong, mainly because its motivation was simplicity and easy to read and easy to teach. All right. And if you design it where your code is only going to be like maybe a 5 to 10 line function, the declarations being in the beginning versus interspersed to where they're being used, um, it's it becomes a stylistic question, right? But when you have like a 50, maybe even 100 line program, even hell, even the programs of the size that I showed earlier, some of those situations do become apparent. Okay, but that's only because of the way the program was written in Wirt's eyes. All right, and it was a stylistic choice from his standpoint versus in many ways. Um,
What wasn't
and
it done? Wasn't it done also though to kind of ease the whole creation of a compiler?
yes, it was that was the main reason. It was a one pass compiler. The Since it's a single pass compiler, parsing all your types uh, parsing in that particular order, having an implicit order being there, or an explicit order in this case, makes it easier for the compiler to go in and then just do, okay, while I'm parsing this, parse all the types. These are going to go into the symbol table. Parse all the constants. These are going into the symbols tables. You don't have to recall the previous stage. All right. Um, but I think that has since been well, I won't say that it has been addressed because there's two things. Object Free Pascal and Delphi tend to adhere to the classic single pass methodology that Pascal was encouraging, mainly for backwards compatibility. Um, but languages that were inspired by the module concepts from Modula and Oberon, and I'm mainly talking about Go, has actually figured this out. That the main feature for all of this in modules is dependency analysis, and they figured out a way to actually address this so you could have locality. This is one of the reasons why I say it's a plus and a minus in the successor languages for Pascal, the structured language being there. But again, it depends on how large your system is going to be as to whether or not that become, and how large your functions are going to be as to whether or not that's going to become a very big deal. Um, and a lot of successful programs have been created inside this approach, which tells me, at least at the application level, maybe not so much at the system level, but certainly at the application level, it is possible to design a system where this structured uh, approach doesn't make much of a difference. And if you want a very recent example of this, I think the only one that comes to mind commercially is I think they changed it to C sharp, is Skype, because early versions of Skype, I'm actually almost certain they were written in Delphi, in the Delphi dialect of Pascal, and they ended up using the structured approach, and that didn't really make much of a difference. But I never worked on that particular project personally, so I don't know if a programmer was sitting while working on this, complaining, "Oh my God, this I should be able to just define my integer right here, or define my variable right here before using it." You know, um, there may have been some disciplined approaches to actually address that. Other questions?
Well, and one other comment
Hmm.
is the use of Pascal for larger projects where you have multiple programmers working on it.
Yeah.
And
Hmm.
that's one of the things that really influenced the design of Modula 2,
Right.
where they def- they had basically an interface definition portion and an implementation portion, and you compiled the interface portion, and that was where you could kind of check that everything worked without ever implementing anything. You could see what the dependencies and so forth were.
Right. Hmm. And you saw that with Object Free Pascal and even Delphi. They inherited that feature.
Right.
So when we talk about Pascal here, I'm talking about modern Object Free Pascal. Okay, I'm talking about Free Pascal. please do not confuse this with Pascal in general. I completely agree. If we go all the way back to 70, 76, 77, or even later versions of so usually we're talking about Pascal back then. Standardization didn't happen until the early 80s. You're probably talking about UCSD Pascal, which is the most prolific Pascal that was spread out to many people at that time. You're dealing with fixed size arrays. You're dealing with structured programming. You're dealing with a lot of limitations. So, like some of the stuff that I showed you earlier regarding dynamic arrays just will not work in those older versions. All right. So for the purposes of tonight's discussion, we are focusing on just Freepascal. We're talking about so that's Object Pascal or Delphi.
So does Freepascal then have an interface definition?
Yes. I thought I had showed this, but I can certainly give you an example. Give me this. Let's see. Go back. At least in the unit, there was an example of let's see. Do I have a unit here open? Here. So this is a single unit. Modula does the same thing. If I remember the examples that I've seen, in that the interface here is still next to the implementation. It's just that in the first pass, the interface is what's used for dependency analysis.
Okay, and so you use this when you're defining a unit.
Right.
Okay. And then how do you import? If I was using unit series, how would I? Is there an import then that you use in your program?
Uses is an import.
Okay.
So they switched back to uses instead of using import. From Modula uses import, but you have uses, and that's the same. It's the same thing.
But does it say what it exports?
Not in this case, but because it's only because of the fact that I didn't actually. So if you're writing in the Pascal world, everything that's capitalized and defined in the interface section is an exported symbol. Anything that's specifically defined in the implementation section is not an exported symbol. Now,
so if your function scanning had a lowercase s, it wouldn't be exported?
I don't know, actually. This I've seen in a lot of examples, but I thought that was the same thing, but I could certainly try. That's actually a good, very good question. Let me see. When I defined this, I defined it as a capitalized just because of some of the stuff that I was reading. Example.pass k n. Yeah. So I have to do this. Yeah, it worked. It compiles. So yes, it looks like for units this works this way. You could anything that's in the interface section is a exported function. But anything that's in implementation, so if you want to create helper functions that are not exported, you have to just strictly define them in implementation.
So could you go back to the code where the unit? Okay, so the fact that the function is defined in the interface doesn't matter whether it's capitalized or not.
Yeah.
That is, by putting it in the interface, it is explicitly saying I'm exporting this.
Yes.
Okay. Thank you.
No problem.
I got to go too. Rob, always a pleasure listening.
Thank you, Curtis, for joining. Thank you.
I think Mike came and went. I think he had a bagpipe meeting or something he had to go to.
Oh, not a problem. Not a problem. Thank you so much, Curtis, for joining, and
You
thanks
bet.
everyone else, especially those uh, who are remaining on the stream. For joining. And I'll see you guys on Saturday, and hope to see you, Curtis, next week sometime.
Okay.
All right.
Take care,
Thanks.
sir.
Bye.
Season's greetings.
Season's greetings.